Topic 6.4 Scale Drawings, page 351 in your textbooks. Scale drawings is just a special application of ratios. And the purpose of scale drawings is to provide accurate information about an object which has dimensions that are either too large or too small to be shown on a page. Or in other words, it is fitting any diagram or any picture or anything onto one page. Now, scale drawings can either be an enlargement or a reduction, so you can either go bigger or go smaller to fit it onto one page. And we'll look now at examples to show us what's the difference between these two. Examples of enlargement are diagrams. For example, this Lego block, that is much smaller in real life than on the diagram. Projectors gives us an enlargement of different frequencies or different sizes, and then microscopes can give us pictures which are also enlargements. Examples of reduction are maps, for example, photos. No elephant is as physically as big as this one, but it gives us a true size of or a scaled size of what a real elephant looks like. The house plan also identical to what it is in real life, only on a much smaller scale. A scale drawing has exactly the same shape as the original object, but a different size. All scale drawings should indicate the scale ratio. The scale of a drawing is written as a scale ratio. So the scale ratio is the drawing map length to the actual or the real length. And I'll also indicate it with an D or an M to A or R. And I'm going to use that in all of my examples. Now, before I go on, I need to apologize for the setting out that's so confusing. When I import my PowerPoint, this app that I use to record myself just throws everything around, and I do not have the time to fix it right now. So apologies, just bear with me. If I read this 1 to 100, it means it's the map length to the actual length, which means that the actual length are 100 times greater than the measured on the diagram. And this therefore is a reduction, because the actual thing is 100 times bigger than my diagram or my map. When I have a scale ratio of 20 to 1, it means that my map length is 20 times bigger than the actual thing, which means we have an enlargement of something. It means the scale length on the drawing are 20 times greater than the real thing. So the sketch is greater than the real thing, and therefore it is an enlargement of what we have. Now we're going to look at some examples, and you will see if you follow your textbook that my examples is way quicker and different than that of the textbook. I still prefer my way. If you use the textbook's way, it is fine. Just make sure that you know what you're doing. So if you paid attention, you'd see I have just enlarged my original picture to this one. So let's have a look at how I'm going to do it. So first of all, we're going to convert an example 9 from the scale distance to actual distance. So what I'm going to start off is by always saying this is the map to the actual, which means 1 to 20,000. So I'm going to rewrite that. I'm then going to look at the first question. I'm going to say, find the actual distance if the scale distance or the map distance is 2. And then I'm just going to use the unitary method. So I'm going to say, how do I get from 1 to 2? I've multiplied by 2, so I multiply by 2, and 20,000 times 2 gives us 40,000. I'm going to have then a worded answer. I'm going to say, therefore, the actual distance is 40,000, and I'm going to use the unit centimeters. And that's what I'm going to do with each one of these. I'm going to start with saying the map, or the original, the map to A is 1 to 20,000. They want us to use now 5 millimeters, so the scale distance, the map distance is 5. What is the actual distance? I'm going to say from 1 to 5, I multiply to get there, and I'm going to multiply by 5. 20,000 times 5 is 100,000, and therefore the actual distance, or the distance in the map, the actual distance is 10 or 100,000 millimeters. Now, something that you have to remember is that we don't want to leave answers in unrealistic ways. So nobody's going to say, well, the actual distance is 100,000 millimeters. So we will have to convert it back to sensible unit. So to go from millimeters to something else, I'm going to divide by millimeters to centimeters, which means I'm going to divide by 10. If I divide by 10, it's going to give us 10,000 millimeters, which is still a little bit weird. So you're going to divide by 100, which means that's going to give us 1,000 centimeters. 1,000 centimeters is still a little bit weird. So we're going to divide by another 10, which will take us to meters. And that will give us then 100 meters. So a sensible answer will be the actual distance is 100 meters. So the last example, if we start by saying the map distance to the actual distance is 1 to 20,000, we can still go by saying that this is now 14.3 to what will that be? How do I get from 1 to 14.3? We multiply it by 14.3, which means we'll have to multiply by 14.3. 20,000 times 14.3 will give us an answer of 286,000 centimeters. Now the actual distance then, the actual distance will then be 286, that is an 8, 286,000 centimeters. To give us a sensible unit, we will divide that by 1,000 to take it by 100 to take it to meters. If I divide by 100, it means I'm going to get rid of those two. That's still 2,860 meters. Divide by 1,000 to take it to kilometers. So my answer will be that's the same as 2.86 kilometers. If you need to do the revision on going from centimeters to meters to kilometers, please refer to your previous textbook. For example 10, where we are now going to convert from actual distance to scale distance, I'm only going to do A and C. We're going to do it exactly the same way. So what I'm going to start off by saying is it's always map to the actual distance. Our scale that they give us is 1 to 500. And the question now say, find the scaled length for each of these actual length. So now the actual length for A is 50 meters, which means we put 50 on this side. Now I ask myself, how did I get from 500 to 50? In this case, it was pretty easy. So all I had to do was I had to go from there to there. I had to divide by 10. Now when we do example C, you'll see it's not going to be always that simple, but it's always going to be quite easy. What I do on the one side, I do on the other side. So we're going to say 1 divided by 10. And 1 divided by 10 will give us an answer of 0.1. Therefore, the scale distance equals 0.1 and the unit is meters. Now 0.1 meters looks a bit weird, so what we're going to do is we're going to say that equals times 10 times 100 to take it to centimeters. If I multiply that by 100, it gives me 10 centimeters. That equals 10 centimeters. Let's look at question C, as I'm running out of time. If I look at C, we're going to say again M to A. They say that the actual length, the unit or the scale or the ratio is 1 to 500. Now they say the actual length is 4550. They want to know what is the scale distance. Now how do I get from 500 to 4550? What I'm going to do is always going to go to 1. That's why it's called the unitary method. So to take 500, I'm going to divide by 500 to go to 1. And then I'm going to multiply by 4550 to get to that. What I do on the one side, I also do on the other side. And again, you don't have to write every time the answer. So you don't have to say 1 divided by 500 and write it down. On your calculator, you'll say 1 divided by 500, multiply by 4550, and you will get an answer of, the answer would be 9.1 millimeters. Now that is a sensible answer, so you can say that the scale distance equals 9.1 millimeter. I would like you now to pause this video and do exercise 6D, 5 and 6, only numbers B, D, G and H, and only the first and the last, which is the I and III questions. Once you're done, you can proceed with the video. The last topic that I want to discuss now is a thing called the scale factor. Now it's very useful if we can start as a ratio with 1 to something. The second part of the ratio will then be the scale factor. Scale ratios do not start with a 1, then you use the equivalent ratios to make it 1. We'll look at some examples to do it better. But before we go on, I'll quickly refer to our little sketch that we have over here. And this thing, all it says is, if I'm going to use the scale factor to go from the scale distance to the actual distance, then we're going to multiply by the scale factor. From the actual distance to the scale distance, I divide by the scale factor. I'm only going to use this method if the questions say, use the scale factor to calculate. If they do not ask us to use the scale factor, we will do as we've done the previous examples. Now in this example 11, they say determine the scale factor. State the scale factor in the following situations. So for this question, we are simply going to say it's always map to actual distance, nothing changed. 4 millimeters on a scale drawing, so 4 millimeters on a scale drawing to 50 centimeters on actual. Now I'm going to say 50 centimeters, take that to millimeters, so I'm going to multiply it by 10, and that will give us 4 to 500 millimeters. Now it's important that the units are the same. What I have to do now is make sure that I have a 1 at the first point, which means to get a 1 I'm going to use the unitary method. If I want the 1 here, I have to divide by 4. So I'm going to divide by 4 on both sides, divide by 4, divide by 4, and 500 divided by 4 is 125. So the scale factor will be is 125, which means that the actual, in real life, the real model will be 125 times bigger than what it is on our drawing. The second one is exactly the same, an actual length, so again, M to A. The actual length is 0.1, and it's represented by a scale drawing, which means on the map it is 3 centimeters. Now again, I'm always going to go to the smallest unit. So I'm going to change 3 millimeters. This 3 millimeters, I'm going to multiply by 10, and that's going to give me 30 millimeters. So on the map, it is 30 millimeters, and the actual length is 0.1. To find out what's the scale factor, I have to get a 1 on the left-hand side. So my ratio starts as 1 to something. To do that, I'm going to divide both sides by 30. I'm going to divide by 30. 30 divided by 30 equals 1, 2, and 0.1 divided by 30 equals 0.00333. That's repeating, which means that the scale factor equals 0.00333. Some calculators also give this answer as 1 over 300, which means that in actual life it will be 300 times smaller than what it is on the scale drawing. I would like you now to pause this video and do the following questions. So 7 all of them, 8 column 3. Thank you for watching, and I hope to see you soon.